all of the events. And you say, do I have to know all of these? Well, no. But I would like you to keep in mind certain major features as we go through geologic time. For example, the oldest evidence that we have for the origin of life exists within the Archean. If you can remember a specific number, that's fine. But I'm more interested in your putting things in terms of a timeline based upon the 4 eons. And then once you're into the Phanerozoic, also the 3 eras, Paleozoic, Mesozoic, Cenozoic. So we get the earliest evidence for life taking place in the Archean. We find that the rise in oxygen, where we're starting photosynthesis, this is also taking place in the Archean. At the beginning of the Phanerozoic, we get this major explosion of life. And it's within the Paleozoic that we find the first evidence for land organisms. So in terms of major events taking place for life forms, I would like you to have those registered in your mind. In the Paleozoic is when you get the first land plants and the first land animals. This is the Paleozoic from here all the way to there. The end of the Paleozoic is the largest mass extinction that we have on Earth. And then we have our old friend plate tectonics. Not again. Divergent boundaries, we hashed this out yesterday.
On the exam, as you said, we're going to be sketching and diagramming. Is the majority of the exam similar to what we've already seen, or is it a section of it going to be multiple choice or fill in the blank, or is it mostly going to be writing out our observations? What's the format?
He just shakes his head.
I will ask you some questions about the last 2 field trips in the true-false form. I've already tested you on the Enchanted Rock. But on the X Lake trip and the trip we're doing Thursday, there will be some 10 or so true-false questions. I'm going to ask you about some definitions. I will give you the definition and you will tell me what is being defined. It can be stated in a word or two. You will have a relative time puzzle. Superposition, cross-cutting relationships, unconformities, faults, what came first, what came second, we did some of these here in class. I'll put one on the final. I do that so you don't get totally bored when you get to I will have some multiple choice on there. And we'll have sketches. And you can count on having a sketch, something to do with plate technique.
What was that?
You definitely will get a question, something, I'll ask you to sketch something. It'll be a side view. I might ask you, for example, to sketch, other than plate tectonics, I might ask you to sketch a reverse fault, label the football hanging ball, maybe sketch a nonconformity, might be a disconformity or nonconformity, and then you will sketch what that would look like. That's the kind of things that I would be asking about.
On the relative triangle, like we'll have a sketch.
I will give you a sketch. I will let you know what is igneous, what is sedimentary, what's metamorphic. Yeah, well, you'll know that, and I'll point out if there are any faults, what they are, and if the erosion events, those are valid events, I'll mark those for you as well.
Like they can tell you what came first, like we did before in the AD.
That's right. Yeah. So from the oldest up to the continental divergence, oceanic divergence, new crust being formed. This is the trailing edge of a plate. North American plate has its trailing edge is oceanic, its leading edge is continental. I will not ask you to locate plates. I've done that. Just if you were on the house that
I'm like retesting on things I'm good at.
Well, I sometimes rehash things.
Yes.
All that.
The convergent, the three different convergent boundaries. Noting the earthquake positions, the volcanic activity positions, what goes under, what rises on top. Where's the asthenosphere in these pictures? Bottom. The orange here, right? That's the asthenosphere. Like this side view of these processes, that's the sort of thing I would be asking you to reproduce. If you want to draw it in 3 dimensions, it's okay. It takes forever. Bring your colored pencils.
Seriously?
Can we bring?
Well, you can bring them all you want, but
What did your meat?
magic markers.
Like those days in your face.
Figure things.
If it's okay. On the side of our
Right,
eyes.
you know, you got artistic ability. Plus, I will not grade you on artistic ability. You've seen me sketch things on the board. Transform faults. The oceanic event to the continental. We went through all of our discussion. Earthquakes, P waves, S waves, two body waves. We talked about the age of the ocean floor. The reason that we get the oldest material over here about 180 million years, that's right around when Pangea broke up. Since Pangea broke up, we are, from that point on, producing new lithospheres. So the first lithosphere to form after that breakup is the blues. The stuff that's forming right now today, the bright red. Here, you remember, are the actual plate motions with the rate that they're moving. With all of the names, except for the standard plate and the circular plate. Wilson cycles, talked about those. Supercontinent timeline. Did you remember the supercontinents in their proper order? You remember the oldest, 2,500 million years, that's the boundary between the Archean and the Proterozoic. The boundary here at 2,500 million years, that's the boundary between the Archean and the Proterozoic.
And that's the heavy bombardment, right?
No, that's back here.
Oh, that's the first one. Sorry, my bad.
Here's 3,900. That's the boundary between the Hadean and the Archean. That's Kenner, correct. And that's marked by the Kenoran orogeny, which is the worldwide event. Then we know that Columbia and Rhodesia were assembled during the Proterozoic. We know that the breakup of Rhodesia is at 750 million years ago. And that started the development of Pangea. Pangea finally assembled, as far as the total assemblage, in the Mesozoic. Please make sure you've got that straight, because we noted the Ouachita orogeny here in Texas was at 300 million. That's in the Paleozoic. But the overall assembly of Pangea continued after that, all the way up into the Mesozoic. So it began, the assembly of Pangea really began in the Paleozoic, but it culminates in the Mesozoic.
Dr. Freed, what is the event that occurs between the Proterozoic and the Phanerozoic? Yeah.
That's that Cambrian explosion of light at 542. That'd be at the very base of the Cambrian. This morning we talked about the igneous, sedimentary, and metamorphic rocks. And when we look at the igneous rocks, we also want to remember about the melting business. And what drives the melting? There are several types of aspects of melting. Decompression is clearly an important one.
Decompression is divergent.
And composition. So with decompression, you're looking at melting that's taking place in divergent concrete. And also, be sure to remember that that's also the process for the mantle fluids, hotspots. It's decompression melting. That leads directly then to igneous rocks. The fluid-induced melting, that's in the two convergent situations where you had subduction. And that's the higher the content of fluid, namely water, the lower the melting temperature. And then thirdly, we find with composition that the felsic materials melt at a lower temperature than the mafic. About 700 degrees Celsius for the felsic, about 1200 degrees Celsius for the mafic.
But mafic rocks actually erode faster than felsic rocks?
They do.
Celsius.
About 700 degrees. Mantle rock, the ultramafic materials, that will melt around 1700 degrees. We noted the rock cycle. All igneous rocks start from magma. Then we have the weathering process that takes place. Of course, weathering is going to be occurring not only on igneous rocks, but sedimentary rocks are going to weather and metamorphic rocks are going to weather. What kind of weathering processes do we have available? Chemical and physical. And the most common chemical agent is water, and then comes carbonic acid if you have carbon dioxide. We have the liquefaction process to get sedimentary rock. Notice that for metamorphism, you can have igneous rock being metamorphosed, you can have sedimentary rock being metamorphosed, and in fact you have metamorphic rock which is going to develop into more intense types of metamorphic rocks. So you take a slate, for example, can be altered to a schist schist in turn can be altered to a gneiss. So metamorphism is taking place inside that box there too. And anytime you've got metamorphism, immediately the little light goes on and you say proto-man. What was there first to be metamorphosed? So if you see on your little relative time cartoon I'm going to provide, if there's a metamorphic rock there, it's not sufficient just to say metamorphic rock is process number 3 or 4 or whatever. We've also got to remember that something else happened before that metamorphism occurred. So the fact that you've got a metamorphic rock is really telling you that there are 2 times. The time of the existence of the parent rock, the protolith, and then the time of the metamorphism. Oh, decompression melting. Fluid-induced melting. Where does all this water come from? The ocean. Plus, remember the water structure within the minerals. By that I mean water which is required to be present. Metamorphism, the various types, most important as far as looking at the big picture of plate tectonics is, of course, regional metamorphism, where you have continental encountering continent. Sedimentary stages. We talked about rivers and their expenditure of energy. Do they do work? They also carry things. Remember the load business? Bed load, suspended load, desaltation, saltating load, dissolved load. That's all in rivers. When we looked at wind, we were noting that you get bed load for wind, but that's different than the bed load for water. The bed load for wind is talking about the saltating sand particles. The suspended load for wind is going to be the clay-sized material, which can be carried way up into the high troposphere. That would be the clay size, the very small dust size. The bed load is the saltating sand grains. And the heavier stuff is all left behind. So wind is a pretty good sorting agent for leaving behind. Remember the desert pavement we talked about? And that we also emphasize that in the desert, what's the most important agent for sculpting the landscape?
Water.
Water. If we're living in Arizona this last week, you would be well aware that when you have water, there's a lot of work done by that water. They had all that flooding in Phoenix taking place. So I grant you that you don't have much water all the time, but when you do get it, it's very effective in sculpting the landscape. We talked about ice and the various features that ice produces. Remember we talked about till versus outwash. Till being the stuff dropped directly from the glacier. And then outwash, the moment you melt any water, is going to start to alter pre-existing deposits. We talked about the differences as you go down toward the mouth of a river. We noted the youthful stage, the mature stage, and the old age. Talked about levees. We talked about groundwater. As you'll see in your field trip on Thursday, you'll be in the middle of the rock, standing in a cave. And that cave was produced by chemical weathering taking place below the water table. In other words, that area was completely saturated with water. You get some carbonic acid because the source of the water is from the atmosphere. You're getting a weak carbonic acid, but that's sufficient to do the job. On that cave trip, the guide might be telling you that the cave was being produced by this river running through. Well, just smile and sort of just nod your head. You know, that's what he's paid to say. I'm telling you what I'm paid to say. And that is that that's buoy. That's not the case. H-O-O-B-Y.
I get these scientific terms written down here, so I know.
And then once the water table drops,
Oh.
immediately what's going to start happening? Filling in the cave. All these stalactites, stalagmites, columns, flowstone around the edges on the floor, that's going to seal up the cave if it goes to completion. So it forms below the water table. It's a solution process. Then it is filled in above the water table, and that's a deposition process. Well, we talked about the carbon cycle. Looking more at the carbon dioxide, but there are other carbon-based items, methane, for example. They're talking now that Japan and the U.S. are doing experiments to try to see if they can recover the methane hydrates, which are at the bottom of the ocean, where you get the methane molecule CH4, which is surrounded by a cagework of ice. And they say that the methane deposits that are currently in existence, if they were taken out and used to generate energy, it would represent more energy in that methane hydrate deposit than all of the fossil fuels that have ever been burned throughout all history.
There's a lot of fossil fuels.
And so you see dollar signs suddenly
Yeah.
arriving in everybody's eye.
I went to that movie Dallas, so
And the real danger, of course, of methane is a much stronger greenhouse gas than anything else up there. About 20 times more powerful than carbon dioxide. And we related weathering to the carbon cycle, bringing in temperature differences. Weathering reduces carbon dioxide in the atmosphere because the carbon dioxide combines with the water to produce carbonic acid. So you're taking carbon dioxide up. The lower carbon dioxide leads to climate cooling. That's part of the whole idea of removing carbon from the atmosphere as an issue. That should lead to cooling because you're taking it out of the system. But the lower temperatures and decreases in carbon dioxide reduce the weathering. Reduced weathering rate leads to an increase in atmospheric carbon dioxide, which in turn leads to climate warming, and you just go around and around and around. Hydrologic cycle. Remember the short cycle, marine basins evaporate, marine basins precipitate. The long cycle is going on to land. You can get water locked up in ice for millennia, thousands of years. All of this is part of the cryosphere and the hydrosphere. Remember we talked about the freshwater versus saltwater? Just 4% of all the water available is freshwater. And 3/4 of that is locked up in ice. Where Brownwood is having water problems. Brownwood is to the north of us. And they have a Lake Brownwood, which is a reservoir. That's going down, and so they're concerned about getting a new source of water. They're drilling, figure 3,000 feet below, they'll encounter two groundwater reservoirs, one being, the first one they say is saline. So if they recovered that, they would have to take out the salt. And the second one, which I guess is deeper, has a lot of radioactivity. And you have to find some way to remove that. Their other choice is to start using sewer water and recycle that for drinking water, which is very expensive.
All of those are expensive.
Yes. But money never comes into play with these issues.
Not right now. It's still fairly cheap. And there's still the water available.
But that's all right, because we'll just have our grandkids take care of it. We talked about this already. Yeah, the cells, we talked about the Coriolis force producing the trade winds and the westerlies. So now every time you go to Comfort, Texas, at 30 degrees north latitude, you'll just feel different the moment you head up towards Fredericksburg. feels different. My wife and I go to the grocery store just to get out of the Hadley cell and into the barrels. We'll sign on the side of the road, you are now leaving the Hadley cell. Oh, we talked about the Milankovitch cycles, the eccentricity, the tilt, giving us the climate. Precession. We talked about that in terms of this cyclical kind of, to say it's a repetition of hot, cold, hot, cold, hot, cold. In this case, we have a record going back 1.8 million years. This is the last glaciation. Remember that was the Wisconsin? And this is today, right there. We also noted ice cores provide fossil air, so we can get a measurement of the major greenhouse gas content. We notice a direct correlation between the temperature, which is in the black, and the carbon dioxide in the blue, and methane in the red, slightly more orange in this projection. Then they track one another. And again, this is the Wisconsin glaciation, and that's today. And we noted all of our spheres of influence. We mentioned at the beginning overlap. Constantly one affects the other. And in terms of human activities, we're becoming more and more aware of the issues of pollution, whether it be water or air. We also have land pollution. Today's global distribution of life, with the development of global warming, the prediction, of course, is that life will become even greater concentration further north. We're already noting farming changes with regard to the types of crops grown, the things like the wheat for bread, etc. It used to be grown in the middle of the Midwest, but now it's further to the north. And Canada is now starting to develop their growth of various wheats.
Why are things moving to the north?
Because of the temperature changes. With the global warming, it's going to be becoming warmer in the zones in the southern U.S. It's going to become more temperate further to the north. By that I mean less intense freezing.
Will there be more intense heat then in the South U.S. as an example,
Yes.
driving us farther north?
Yes.
Do we see a similar phenomenon on the South?
Yes.
Heading.
It's a mirror image.
Okay. And plants are affected negatively by the heat, and so they're migrating north as well?
That's correct. And organisms, land animals, the same way. Marine organisms going to be affected by those temperature changes. Probably some species would prefer that. I mean, that's obviously you're carrying things to an extreme, very high intensity of warming. As to whether that's going to proceed up to that point, we don't know. That's really where the debate is. So you're going to, tomorrow morning, put your thinking cap on. Very still. Then on Thursday, you're going to put your party hat on. We're going to go field tripping. And then you're going to have to dig that mindset out of hibernation, put it on for your final exam on next month.
And you gotta put your Google hat on. You gotta Google your brain, right?